Today we will do quadratic equations. I will skip 1.3 just a little bit on Thursday. I will do that one. I would like you to read that section first. Somebody asked me, by what time does the 1, 2, 3 assignment due? I think that's due today, is it right? Let's see, 11:20, 10 more minutes. I called at 9 because 11:20 they actually rejected at 11:20. Okay, there are 4 methods to solve quadratic equations. The first one by factoring, the second one by square root property, and then the third one by completing the square, and then the last one by formula. I get the question, will you ever go over the quiz? No, I will not go over the quiz, but I will post the solution in the assignment page. So let's say for you, I will put it here. Give me a second. This is your student view, right? So later on, I will post it here. So right above this file here, I will post the solution there. Now then you can look at that solutions. Then if you have further question, you can ask me during my office hour. But I will not spend my my class time to answer quiz question or whatever that we can just go over during my office hour. Okay. Go back to this. It's not wasting time, but I prefer to say that we have material for the class that is not enough. Even the material for our class is not enough with the time we have. Okay, such that if you have that kind of question, like to serve you only, I'd rather you ask me during my office hour. Okay. Yeah. Now, of these 4 methods here, the fastest one is factoring, but the thing is factoring method does not always work. Square root property only work when it has certain pattern, and completing the square always work, but best only in certain condition. Certain situation. And the last one, by formula, always work. I should say always works. But slows. So today, what we will do, we will spend time to go over these 4 techniques here. The first one is something we have done before, or at least quite easy to do. Okay. Now, all of these are actually you have done before, but you will see I focus especially on the last one later on. Okay, so I will go over 1, 2, 3 quite not too fast, but fast enough. Okay. Now, let's see between number 13 to 24, solve the equation by factoring. I would like to write a note here that if an equation in my class, if a quadratic equation is solvable by factoring, then you need to do so. Using other method will get at least 1 point penalty. Okay, in my class. The reason is because if it is something you can factor, then you can do it by factoring. Okay, don't do it by other method. I already answered the question from somebody else. Will you ever go over the quiz? My answer is no. Will you go over the 1, 2, 3 assignment today? No. No, 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 no. I will not go over the quiz. Okay, I will post the solutions on the quiz page. Okay, then if you have questions from there, you can ask me during my office hour. Okay? No, I will not go over that. Okay, again, for a quadratic equation that is solvable by factoring, then you need to do it by factoring. If you use other method, then you will get at least 1 point penalty. Now, 1 point penalty if you get the answer right, but using other method. What if you get it wrong, even though after you use other method, then you basically lose all the points. Yeah, it's something factorable. You don't factor it, you use other method and still get it wrong. So wrong method, wrong solutions, I have no reason to give you any points, right? Okay. Thomas, why are you so so strict? I'm preparing you for calculus for business. Okay, plenty of students in this class will be there. So if you use other method, then by the time you go to calculus, you will get too slow. I mean, if I were the one in your calculus for business class, and I know you don't have, you don't know how to do factoring, you don't know how to identify if a quadratic equation is factorable, solvable by factoring, then I will really ask you to leave the class. I will ask you to drop the class. You don't belong to calculus class. Okay. Now, then for me to prepare you to be that kind of student, then this is the starting point. Okay, we start from here. And how do you know if a quadratic equation is solvable by factoring? Then try to factor it. Okay, try to factor it. Another, of course, there are some cases that, like especially the trinomial one, right? The trinomial one, sometimes you wonder, oh, can I do it by factoring? Then I will teach you a way to identify if that quadratic equation is solvable by factoring. Okay, but under no situation you're supposed to solve it other way if it is solvable by factoring. Okay. Yeah. No, I'm not trying to make it hard for you, but I'm preparing you for a calculus, right? You need to transition there. But Thomas, why do you worry about my calculus? That's something I do later. Hey, you know what? When you pass this class, you bear my name. Okay, you bear my name. Okay, and if something you can do so in 40 seconds, you end up doing it in 2 minutes. Later on, you will be the one keep on complaining, Thomas, I don't have time to do this. I don't have time to do that. Dude, your method is wrong. Okay, and you don't listen to me. So what do you want to do, right? Okay, so I'm preparing you for your next level. Okay, so that you don't need to get scared anytime you see math anymore. And on the other hand, one of the learning skill is really follow your teacher's direction. You know, okay. Don't give me that excuse. I heard this before, not from this class, but I heard this from other classes and also my previous college algebra, saying, but Thomas, my teacher actually taught me that way. My previous teacher taught me this way, so on and so forth, just different from my way. Listen, that teacher that you took before failed you. Okay? So either it's your fault or that teacher's fault is not my fault. How about listen to me this time? Okay? I think that's fair enough, right? Okay? You want to start anew? Just do it right. Okay? Yeah. No, I want to bring you to the right direction with the correct learning skill. And of course, one of the skill you need to learn is being humble, willing to learn. Okay? Stop being like, I call that arrogant because it is the true definition of being arrogant. Like if you insist on your method and you don't want to learn from your teacher, then that's arrogant. Okay? But Thomas, you sound arrogant yourself because I'm your teacher. I can enforce my method to you, right? Okay? But no, you cannot enforce your method to me. I'm not the one learning from you. Okay? And especially because once you pass my class, you bear my name, then I want you to actually bring my name and bring glory, math glory to me. Okay. No. It's actually about you though. Okay, it's about you. If you do well in your next class, I'll be happy for you. But of course, then I need to also shape you into that form, right? Okay. Now, number 14. 9x squared minus 1 equals 0. See, if you try to use quadratic formula here, you will spend too much time unnecessarily because you can just factor it, right? This is 3x plus 1, 3x minus 1 equals 0. So, and then you get 3x plus 1 equals to 0, or 3x minus 1 equals 0. So x1 is negative 1/3, x2 is 1/3. Okay, now when you do solving equation by factoring, solving quadratic equation by factoring, keep in mind that the other side has to be zero, because we rely on zero factor theorem, zero product theorem. So the other side has to be zero. Zero product theorem says A times B equals 0 implies if the product of two factors equals to 0, then either one of the factor must be 0. Okay, that's why the other side has to be 0. And then you factor this side. Okay, so the other side has to be 0 first, and then you factor the other side. It doesn't work with one, it doesn't work with other number. No, it only works for 0. Now, that's for number 14. Let's see more. Number 18. That's 4x squared plus 12x plus 9 equals 0. Now, in case you wonder, Thomas, then how do we know that a quadratic equation is solvable by factoring? Now, once you set one side equals to 0, then you wonder if this is factorable, right? How do we know that it is factorable? Now, you try to factor it on your own first without doing this checking. Okay, if you look at this, for example, you see, oh, this is actually the base here is 2x. The base here is 3. The product is 6x. When I double down, it matches 12x. So it must be factorable to be 2x plus 3 squared equals to 0. That's a perfect square. So when you do, so 2x, something squared equals to 0, that thing must be 0. So x equals to negative 3/2. Okay, now the thing is, sometimes you try to factor this way, that way, doesn't work. So Thomas, then how do I know that it is factorable? You will look at the discriminant. The discriminant is a square number. the discriminant is a square number. So if you try to check that on this problem here, how do we know that's factorable? Then look at the discriminant. The discriminant is b squared minus 4ac. The b here is 12. The a is 4. The c is 9. I get 0, which is 0 squared. It's a square number. Then it must be factorable. Okay. Now, of course, if you can just go ahead factor it, go ahead factor it. You don't need to check if it is factorable or not. Okay. After all, what they want you to do is to solve by factoring. Next, number 22. Number 22. Negative x squared plus 8x equals to 12. Set one side equals to 0. And then I don't like this negative coefficient there. The negative leading coefficient. Let me multiply by -1. So I will get x squared minus 8x plus 12 equals to 0. Then from there, I go on with the factoring. Can you finish it up? So it's not that you cannot manipulate the equation. You can manipulate a little bit. Like in this case, we don't like the negative coefficient, right? Then multiply it by -1 to make it look nicer. Because leading coefficient 1 is something we can solve. We can factor easier. I think this is -6 and -2. Right? So then you will get x equals to 6. X equals to 2. Okay. Last example. Number 24. This number 24, we have 1/8 x squared minus x minus 16 equals 0. That 1/8 is kind of like disturbing. Let's multiply by 8 just to make it a lot nicer. So we get x squared minus 8x minus, what's that? 128 equals to 0. Right? So that 128 is 16 times 8. Now, then when I try to factor, this must be x times x plus and minus, right? And what times what is 128, but the difference is 8. Now, it happens to be the number we have here, 16 and 8. This is 8, this is 16. So you will get x1 is -8, x2 is 16. Because it is a quadratic equation, then it should have two solutions. But Thomas, then how about number 18? You have only one solution there. Yes, it actually has two solutions here. Both of them the same number. So usually we denote that by x12. Not x12, that's x12. To be more precise, x1, 2. Okay, later on in chapter 3, we will see that this is a solution with double multiplicity. It happens twice at the same place. It happens twice at -3/2. Now, that's for solving by factoring. We go on. Solving by extracting square root. This is the term 4. In other words, we solve it by square root property. Which basically say the following. For C non-negative, it has to be non-negative. For C non-negative, okay, blah squared equals to C implies blah equals to plus minus square root of C. Okay, so if one side is a perfect square, something square, it doesn't have to be x squared. It doesn't have to be x squared. It can something complicated. Okay, equals to C, and that C doesn't have to be a square number. Okay, now the easy example you can see here, number 26. Number 26, x squared equals to 144. So you see on the left hand side is perfect square, right? Something square. And on the right hand side is a positive constant. Now once you have that pattern, then you apply square root to both sides, but don't forget to use plus minus. Now then, we simplify a little bit, and I would like you to write this in split form. x1 is 12, x2 is negative 12. I want you to split it. Now, number 28. Number 28, x squared equals to 32. Now, 32 is not a square number, but still positive. So I can apply square root property, x equals to plus minus square root of 32. Okay, now, but you need to simplify that square root of 32 though. Square root of 32 is square root of, what is the square number, a factor of 32? What is the largest square number, a factor of 32? (16), that's right. So this you can visualize that this is 16 times 2. Okay, now square root of 16 is the 4. Square root of 2 stays inside the house. So when I split this, x1 equals to positive 4 radical 2, x2 equals to negative 4 radical 2. Okay, now number 30, what we can learn from here. Number 30, 9x squared equals to 36. The idea is we want to see the left-hand side as a perfect square. So for this one, there are actually two methods. The first method, which I think most of you have in mind, you divide by 9 first. Right? I think this is the simplest way to look at that. You divide by 9 first, and then you apply square root. So that will be x1 equals to 2, x2 equals to 2. Okay, now that's the first method. There's another method. I don't really like this, but I have to admit this is one acceptable method. You look at that 9x squared as 3x being squared. You see that as 3x being squared. Then you apply square root property. Okay, so your 3x equals to positive 6, 3x equals to negative 6. Therefore, x equals to 2, x equals to negative. Okay, you still get the same answer. You still get the same answer. But the key in step 2 is to look at that as a perfect square first. Okay, but I personally prefer the first method. I personally prefer the first method. Now let's modify that question number 30 a bit. My type of question, for example, suppose I have instead 9x squared equals to 32 instead of 36. So what I will do is I divide by 2 first. I mean divide by 9 first, and then apply square root property. Okay, simplify whenever possible. This is plus minus 4 over 3 square root of 2. And then I split it. So x1 is 4 over 3 square root of 2. x2 is negative 4 over 3 square root of 2. It gets more complicated, huh? Now what happened here, you divide by 9. The square root of 32 happens to be not a nice number. When you divide by 9, it's still not a nice number, but at least the 9 is a square number. What happens if I change that 9 becomes, let's say, 6. So 6x squared equals to 32. So x squared equals to 32 over 6. Oh, I can reduce this. This is 16 over 3. So x equals to plus minus square root of 16 over 3. But you see, you will have square root of 3 at the bottom, right? You will have square root of 3 at the bottom. Let's rationalize the denominator by multiplying by 3 over 3. Then it will become x equals to plus minus, I wonder if you can follow me, 4 over 3 square root of 3. Can you follow me? Now that's because this becomes, that's because this is plus minus square root of 16 times 3 over 9. Now the 16 and the 9 goes up, becomes 4 over 3. Okay, now then split that. Now your textbook, when it writes the solution, there's a big chance they don't split it. But I want you to split it for a reason you will see much later. Okay. Then what happens if we have, for example, number 36? I think I need space. Give me a second. Number 36. We have 4x plus 7 squared equals 44. They just choose random numbers there. 4x plus 7 squared equals to 44. So you see, this is something square, and this is positive constant. Right? So I can apply square root property. That's 4x plus 7 equals plus minus square root of 44, which is plus minus 2 square root of 11. Then subtract by 7. Divide by 4. your textbook may write this as the final solution. But for you, I would like you to split it. So x1 equals to negative 7 plus 2 radical 11 of 4. X2 equals to negative 7 minus 2 radical 11 of 4. Any questions so far? No. Now, question number 38 is actually not really related to what we do here, but it used the same technique. Number 38, we have x plus 5, x plus 4. Okay. X plus 5 squared equals to x plus 4 squared. Now, the principle again is when I apply square root to both sides, I need to use plus minus. So when I apply square root to both sides, I get x plus 5. It cancels the square, right? Okay, but on the right hand side, maybe I write it this way. So that will be square root of x plus 5 squared, and this is plus minus square root of x plus 4 squared. Now the left hand side, the square root cancels the square. The right hand side, same thing, the square root cancels the square. But I have the grouping there. Now remember I told you to split it, right? Okay, for this reason. So what happened then, we have the first case, x plus 5 equals to x plus 4, or x plus 5 equals to a negative of x plus 4. Now the first branch here gives us no solution. The second branch will give us some solution. Negative x minus 4. So it will be 2x here. This is negative 9. So x equals to negative 9 over 3. Okay. So in some sense, you look at this as your perfect square. This is your perfect square. And this is your quote-unquote your positive number. See it that way. So that's for square root property. Go on further. How about completing the square? Theory, just to remind us. Now, a perfect square, x plus a being squared, is equal to x squared plus 2ax plus a squared. Now notice that this guy here is the square of a. The square of a, and that a is obtained from the coefficient of x divided by 2. Okay. Now notice that the leading coefficient here has to be 1. The coefficient has to be 1. The coefficient of the square, x squared, needs to be 1. So basically, to complete, for example, x squared minus 6x, what we will do is the leading coefficient has to be 1. The leading coefficient has to be 1. Okay, and then you take the coefficient of x, take the coefficient of x, divide it by 2. The coefficient of x here, divided by 2. That's how you get your a. In this case, the a is 3. Now, whatever the quotient, you square it. So always divide by 2 and then you square it. Okay, so to complete this expression, x squared minus 6x, we add 9. X squared minus 6x plus 9 is x minus 3 squared, where that 3 minus 3 here comes from this minus 3. Okay, so the leading coefficient has to be 1. The coefficient of x divided by 2. The quotient, you square it. Now this 9 here is what you add. That's the procedure. Okay, but again, the leading coefficient has to be 1. What happens if it is not 1 times? Then make it 1. Let's take a look on number 40 is not interesting because it's actually factorable, but let's do it anyway. Number 40. Number 40. X squared minus 2x minus 3. This is factorable, so you're supposed to do it by factoring. Okay, this is x minus 3, x plus 1, right? So x equals to 3, x equals to -1. But to illustrate completing the square, then we do it this way. So x squared minus 2x minus 3 equals to 0. You move the constant to the other side first. Move the constant to the other side first. Now you see that now the leading coefficient is 1. The leading coefficient is 1. Now then the coefficient of x, take the coefficient of x divided by 2. Whatever the quotient, you square it. That's the number you will add to both sides. So x squared minus 2x equals to 3, right? Now you will add that 1 to both sides. Okay, that's the 1 you add to both sides comes from here. Oops, you can't really see that one now. No, it's not visible. Don't do that. Then on the left hand side, I will get x minus 1 squared. On the right hand side, I get 4. Now, then from here, you go on with, continue with square root property. Now, because of that, you will see completing the square method is best when, or maybe I write it down as a note. Completing the square the square method is best when the leading coefficient is 1, the coefficient of x is even. Okay, I think I have to clarify that's best when that n not factorable. Because factoring is still the best method if it is doable. If we don't split it, does it make it wrong? You will see you are not done if you don't split it. You won't be done if you don't split it. Let's see. Let's see. For example, here, right? If I continue from here, then you will get x minus 1 equals to plus minus 2. Now, if you don't split it, then you don't get that 3 and negative 1, the supposed answer. Right? Okay. So you will get x equals to 1 plus minus 2, and then you go on, x1 is 1 plus 2, which is 3, x2 equals to 1 minus 2, which is negative 1, the supposed answer. Right? That's why you need to split it. That's why you need to split it. Okay, let's do example from here. Number 42. Number 42, we have x squared plus 8x equals to plus 14 equals to 0. Now, of course, always check if this is factorable or not. Okay, always check if it's factorable or not. You will see in this case it's not factorable. So what I will do is I isolate the variable terms on one side and constant on the other side. Then I check, oh, the leading coefficient already 1 and the coefficient of x is even. Then completing the square method will be the best. It's not factorable, right? I already confirmed it's not factorable. So other method will be factoring is not doable. Then the second best method, once it's not factorable, then the best method will be you do completing the square method. Okay, leading coefficient is 1, then I take the coefficient of x divided by 2, always divided by 2, and then whatever the quotient, you square it. That's the number you add to both sides. Then I continue. On the left hand side, it will be a perfect square. And the 4 here, the 4 here actually coming from this. Okay, that's where the 4 coming from. That's why if I were you, I will always write this. If I were you, I will always write this down on the side note. Okay, because both of them usable in the next step. Then I go on with square root property. That will be x plus 4 equals to plus minus square root of 2. So x equals to negative 4 plus minus square root of 2. Therefore, the solution will be x1 equals to negative 4 plus square root of 2. x2 equals to negative 4 minus square root of 2. So there are two solutions there. Now, I said earlier that completing the square method always works. However, only when Only when the leading coefficient is 1 and coefficient of x is even, it will work best. Now, I will do example question number 44 just to show you that it is completing the square can handle all quadratic equation. Even though in that case, it will not be the best method. Okay. Number 44. Let me write some little comment first. Number 44. 4x squared plus 4x, let's see, plus 1x minus 4x equals to 1. No. Completing the square is not the best method in this case. You will see using formula will be better, okay? But I show you anyway. Because I want to show you that completing the square, it always works. So if you ask me, can I use completing the square Thomas? Yes, you can. Should I use completing the square Thomas? No. Simply because you can do it doesn't mean you need to do it that way. Okay? Yeah. Well, because we have freedom of choice, especially in America, you have freedom of choice, but you don't have freedom of consequence. If you want to use completing the square here, you can, but you will see it takes you too much time. Okay, but I'll show you anyway. The reason it slows you down because when you make it into leading coefficient 1, you multiply by 1/4, or you divide by 4, and the other way to say it, when you divide by 4 to make the leading coefficient becomes 1, then you will start seeing some fraction. You see? Now then, then I need to find out what number I add on both sides, right? Now then, once the leading coefficient is 1, I take the coefficient of x divided by 2. It's a fraction, -1/2, and then I square it. Which means I need to add 1/4 to both sides. I need to add 1/4 to both sides. Now that gives us a completed square on the left-hand side, x minus 1/2 being squared equals to 2/4. Yeah, you can simplify that 2/4. Yes, huh?
Okay, why does it have to be a -1/2? And why couldn't it be just a +1/2? Is there a difference?
Repeat it again.
You know how you wrote on the side? It said the -1/2.
Uh-huh.
What happens if it was just a +1/2? Does it make a difference?
It does make a difference because the way I took from this -1 here. If you make it plus here, then when you FOIL it, you will get x squared plus x plus 1/4. If that were a plus. You see that?
Yeah, I see it.
Okay, so that's why I take from the coefficient of x. Once the leading coefficient is 1, I take the coefficient of x, whatever that is, I divide by 2. Okay, now that portion will be the one you have here. Remember, because this what we have here is actually the FOIL. If you FOIL this part, You get that.
All right, I got you.
Okay. Mm-hmm.
Yes, sir. Thank you.
Welcome. Now then, now the right-hand side here, 2/4, is something you can actually simplify that to be 1/2. But I will just leave it like that because of the following. Because of the following, when I apply square root property, notice that the denominator already a square number, happens to be a square number. So I will just leave it like that, right? This will be plus minus 1/2 square root of 2. So x equals to 1/2 plus minus 1/2 square root of 2. Give me a second, I have a message coming in. Then we can actually rewrite this as, before I split it, I will rewrite it as 1 plus radical 2 over 2, or plus minus radical 2 over 2. Now, when I split it, then it becomes x1 equals 1 plus radical 2 over 2, x2 equals to 1 minus radical 2 over 2. Okay. So when we do completing the square method, the leading coefficient has to be 1. And then whatever the coefficient of x, you divide by 2. Okay. That's the procedure. Now, then why do I say that completing the square is best if it is not factorable and the coefficient of x is even? Well, because when you divide an even number by 2, it is still an integer, right? It is still an integer. So it's easier to deal with in that situation. Okay, you and I, me too, including me, I would like to avoid fraction as much as possible, right? When we have fractions, it slows us down. You and me, though, you and me. It's not that I'm afraid of that. No, I get used to it, right? But I understand you may be afraid of that, and that's normal, okay? And it's also normal then our response is try to avoid fractions too early. Then if you really don't like fractions, then remember, completing square is only best used if leading coefficient is 1 and coefficient of x is even. Okay? But I show you this again just to emphasize that completing the square is actually a method that works all the time. It works all the time. It's just at times it's not the best method. Okay? Under the situation that we have in number 44, it is actually better to use formula. It is actually better to use formula. Now, quadratic formula is as the following. Last method, quadratic formula. The starting point for quadratic formula is the same to for factoring. That is, the other side has to be 0. So let the equation be ax squared plus bx plus c. Then x12 will be negative b plus minus square root of b squared minus 4ac over 2a. The guy inside the house here, b squared minus 4ac, is also known as a discriminant. usually denoted by capital D. That's the b squared minus 4ac. Now, I recommend you to work on that discriminant first before you compute the solutions. So instead of working on the formula right away, I strongly suggest you to do the discriminant first. Okay, example. If I use that number 44, we have 4x squared minus 4x equals to 1. I have to make one side equals to 0 first. Then we see, oh, the a is 4, the b is -4, the c is -1. Then, before I use the formula, compute the discriminant first. The discriminant is b squared minus 4ac. That is -4 being squared minus 4 times a times c. That is 16 plus 16, that's 32. Okay, now then, square root of d is square root of 32. That is 4 square root of 2. 16 times 2. Then, plug into the formula. x12 equals to negative b plus minus square root of d over 2 times a. On the top, you have common factor 4, which I will cancel with the factor 4 at the bottom. So x1 is 1 plus square root of 2 over 2. x2 is 1 minus square root of 2 over 2. Okay, so what I meant is work on the discriminant first. If necessary, apply the square root right away. Not square root property, just the square root. Okay, because 32 is, when you apply square root on 32, you can simplify that a little bit further. Now, the thing is this though. The thing is this. Discriminant analysis. Analysis on discriminant. First, if the discriminant is positive, then there are two distinct, two different real solutions. Second, if the discriminant is 0, then there is one real solution. Third, if the discriminant is negative, then there are two non-real complex solutions. How do you explain that, Thomas? Why that's true? Now take a look on the solution. x12 equals to negative b plus minus square root of the discriminant over 2a. Now imagine if the discriminant is 0. If the discriminant is 0. So square root of 0 is 0, right? Square root of 0 is 0. If discriminant is 0, so x12 equals to negative b plus minus 0 over 2a. But that's basically negative b over 2a only one solution. Okay, now if the discriminant is negative, then you will get x12 equals to negative b plus minus square root of negative number, right? But square root of negative number is complex. It's not real. Correct? Okay. Now we can say more. I will insert that here in part 1. If it is positive, and this is a square number, then the solutions are rational. Rational. And therefore factorable. Now we will use this analysis to answer 1 or 2 questions from here. Number 65 to 72. Use the discriminant to determine the number of real solutions of the quadratic equation. Let's say, for example, I pick a hard one right away, number 70. Number 70. Notice they don't ask what's the solution. They only ask how many real solutions. To see how many real solutions, either 2 or 1 or nothing, we look at the discriminant. The discriminant is b squared minus 4ac. That's 64 minus, I can cancel all this. This is 4. Oh, 4 times 4 times 4, that's 64 also. Equals to 0. So the equation has 1 real solution. In fact, you will see that's factorable. Number 72. 9 plus 2.4x minus 8.3x squared equals 0. Maybe I rewrite that first. Negative 8.3x squared plus 2.4x plus 9 equals to 0. I rewrite it in descending order so that the ABC is easier to see. Okay, the discriminant therefore is 2.4 squared minus 4 times a, which is negative 8.3, times c, which is 9. 2.4 squared is 5.76. This will be plus, right? That will be plus, and then 36 times 8.3. I use my calculator for this. That's 298.8. That's for sure is positive. That's for sure is positive. So the equation has two real solutions. Okay. Now, if the discriminant happens to be a perfect square, like a square number, then the solution will be not only the solution is two real solutions, but we have rational solutions. In other words, that would be factorable. Okay, let's apply quadratic formula into these cases. Number 74. Use red color. Number 74. Compute the discriminant first. Like, okay. See, the thing is like this is factorable actually. This is actually factorable. But suppose you say, oh, you know what? I don't know if it's factorable or not. But the leading coefficient is not 1, so completing the square is not a good idea. Let me use formula, right? Now, when you do use formula, you will compute the discriminant first. That's -1 squared minus 4ac. That is 1 plus 8. That's equals to 9. Oh, that's a square number. So it is actually factorable. Then you don't go on with that formula method. Try to factor it instead. Let me say it again. If the discriminant is a square number, it means it is factorable. Okay, then try to factor it. So Thomas, what happened if I try to factor it, I still don't get it? Then, okay, go on with your quadratic formula, but I will penalize you 1 point. Okay? Go on with your quadratic formula, but I will penalize you 1 point. Now, how about number 76? Then you use factoring method for number 72. Use factoring method. Number 76, the discriminant is b squared minus 4ac. This is 400 minus 300. That's 100. That's a square number. That's factorable. Then use factoring. How about number 78? They tell us to use quadratic formula, but I say, you know what? I only use quadratic formula when I cannot use other method. Okay, use quadratic formula only if other method doesn't work. Doesn't work. So I think I should say other methods do not work. You can think of the quadratic formula as a big gun. It's like that's your last choice of weapon to attack quadratic equation. Okay, that's not because it takes too much time for you to use that. Now, for example, number 78. Number 78 is not factorable. See, the leading coefficient is 1, okay? So if you try to factor it, what times what is 22, but the sum is 10. What times what is 22, but the sum is 10. It's nothing, right? So it's not factorable. Okay, now should I use formula right away? No, I don't think so. Why? Because completing the square will work pretty well. Okay, completing the square will work pretty well. So let's proceed with completing the square method. Negative 10 divided by 2 is negative 5, and then square it. So I will add 25 to both sides. Now it becomes a perfect square. X minus 5 being squared equals to 3. Apply square root property. So x equals to 5 plus minus square root of 3. So from here I split it. X1 is 5 plus square root of 3. X2 equals to 5 minus square root of 3. That's number 78. Let me ask you to try number 80. Number 80, we have 4x equals to 8 minus x squared. I move the x squared to see that it is actually better done by square root, by completing the square method. So apply completing the square method. I give you 2 minutes. Try it, please. Now we add 4 both sides. And then I get x plus 2 squared equals to 12. Applying square root. That's 4 times 3, that's 2 square root of 3. So x equals to negative 2 plus minus 2 square root of 3. Okay, so then I split it. X1 is negative 2 plus minus 2, I'm sorry, negative 2 plus square root plus 2 square root of 3, and then x2 equals to negative 2 minus 2 square root of 3. Let me see, somebody give me an answer earlier. Don't forget the 2 in front of the square root though. Okay, don't forget the 2 in front of the square root. Okay, now let's go on further. So far we have not used quadratic formula, huh? So far we have not used quadratic formula. Let's try with number 82. Let me write number 82 here. Oh, I think I can do that. 2, negative 3, negative 4. Number 82. 2x squared negative 3x minus 4 equals to 0. So I don't think it's factorable. It won't be factorable. Let's see. So the discriminant is negative 3 squared minus 4ac. Thomas, how do you know it's not factorable? Well, they kind of like do it mentally, I don't, but I'm not sure either if it is factorable or not. So let me just check the discriminant. Thomas, why don't you check completing the square? I don't do completing square if I see the leading coefficient is not 1. And actually, even, well, it's 2 here. When I try to divide by 2, this becomes fraction right away, right? And once I see fraction, you know what? No, I don't deal with ugly people too early, because I'm already ugly. Now then, D equals to 9 plus 32, I believe, right? 16 times 2. So this is 41. Now, you see it's not a square number, right? It's not a square number, so it is, we confirm it's not factorable. Okay, so I go to the second step. The second step, x12 will be negative b plus minus square root of the discriminant, which I pre-computed earlier, over 2a. That's 3 plus minus square root of 41 over 4. Finally, I will split it. Finally, we have a question in which we apply quadratic formula. So I split that. X1 equals to 3 plus square root of 41 over 4. X2 equals to 3 minus square root of 41 over 4. That's for number 82. Let me do one more problem. I think number 86 is scary. Don't you think so? Number 86 is scary. Let's try. Number 86. 36x squared minus 24x minus 7 equals 0. I don't know. Maybe it's factorable, but if the number is too big, such that it's too hard to do.
It's plus 24x, not minus 24x.
Okay, plus 24x, thank you. So let me try the discriminant first. That would be 24 squared minus 4ac. I don't think it's factorable. 24 squared is 576. 4 times 36 times 7 is 1000. This is plus 1000. 1008, not 1000. So this will be, I use my calculator. 1584. Is that a square number? I don't know. I use my calculator. It's not. So this is not a square number. Therefore, not factorable. Okay, but it is actually multiple of 16 though. It's multiple of 16. So this is square root of 1584. 1584 divided by 16 is 99. Oh, 99 is multiple of 9. So this is square root of 16 times 9 times 11. Well, at least when you look at that, you know that it's multiple of 9, by the way. This is multiple of 9. How do you know that a number is multiple of 9? That's arithmetic, by the way. A number is multiple of 9 is if the sum of the digit is multiple of 9. So when you add these digits here, 1 plus 5 plus 8 plus 4, that's equals to 18. But 18 is multiple of 9. Okay? It only works for 3 and 9. This method only works for 3 and 9. Okay? Only works for 3 and 9. So the square root of d will become 4 times 3 times square root of 11. That's 12 square root of 11. Therefore, the solutions will be x12 equals to negative b plus minus 12 square root of 11 over 2a. I can factor the 12 on the top. That's negative 2 plus minus square root of 11. And at the bottom, I can cancel that 12 with that 36. So the answer will be negative 2 plus minus square root of 11 over 6. So x1 is negative 2 plus square root of 11 over 6. x2 is negative 2 minus square root of 11 over 6. Okay, your suggested homework. Basically do from the beginning, which is what number? Number 13 to number 95. 13 to number 95. Just do the one that I have here. So you know that I skipped some problems. The one that I don't put the pictures here, you don't need to do it. Okay, just the one we do here. That's 1.4. I put a note. Just the ones you see here. Okay. Okay, that's for today. See you then on Thursday.